Hi everyone, I'm Robel Lemma and my project is titled Airline Reliability and Safety Trends in the COVID-19 Era from Disruption to Prediction. I'm using two large datasets, BTS on-time performance data and FA incident reports covering the first quarter of 2019 to the first quarter of 2024, covering the pre-pandemic, pandemic and post-pandemic periods. My goal is to predict flight cancellation using operational delays, airline identity, and FA safety indicators. The target variable is cancelled, where 1 means a flight was cancelled and 0 means it was completed. Out of 7.63 million rows, only about 3.3% of flights were cancelled, creating a major class imbalance. To make accurate prediction, I combined operational metrics such as delay causes and carrier ID with the contextual indicators like FA reported safety incident, and I'm tracking KPI like cancellation rate, delay causes, and incident per 1000 metrics. My modeling tool includes random forest, XGBoost, and Smots for class balancing. This visualization tracks cancellation rates by carrier across quarters from quarter 1 of 2020 through quarter 1 of 2024. Each bubble shows a carrier in specific quarters with the size of the bubbles representing an average departure delay. I added a vertical red line at 2020 second quarter to highlight the start of the COVID-19 disruption, which had a dramatic impact on airline operations. What stood out here is how cancellation rates spiked during the pandemic for nearly all carriers, but some like Southwest, American, and SkyWest were hit especially hard. Interestingly, even after cancellation normalized, average delays remained elevated in certain quarters, suggesting prolonged operational strain. This visual helped justify my use of quarter-level operational unit carrier and departure delay log as a predictive features. Here, I show a stacked bar chart that breaks down delay causes by percentage for each quarter, like carrier delay, weather, and NAS. During the pandemic in quarter 2 of 2020, you will see that carrier and late aircraft delay jumped while weather delays dropped, likely due to fewer flights. By 2023, third quarter, and by 2024, first quarter, these patterns normalize, showing sign of operational recovery. These visuals helped me realize that not all delay causes are equally useful for modeling. I decided to keep carrier and late aircraft delays, but excluded security delays since they consistently showed low contribution. Uh, this bar chart shows the average uh, uh, cancellation rate for each airline between 2019 and 2024. Compared to the industry benchmark of 3.3%, airlines like Allegiant, Mesa, and ExpressJet had rates well above the average, while Delta, Hawaiian, and Spirit performed much better. I included a side-by-side panel showing the same carriers during the 2020 second quarter, which was the pandemic peak. The comparison shows that smaller regional carriers often had disproportionately high cancellation rates, both during and after the pandemic. It also justifies including operational unit carrier as a one-hot encoded features in the model and avoid assumptions that only large airlines contribute to disruptions. This dual line chart plots FA incident counts against flight cancellation rates by quarter. In quarter 2 of 2020, both spikes occur. However, in quarter 3 of 2023, incident counts peak again, even though cancellation rates remain low. This shows that safety concerns can rise even after operational reliability improves. It expands the project scope beyond just cancellation period to include risk monitoring. From here, I learned that safety metrics and cancellations are not always aligned, and both needed to be analyzed jointly in a future visual dashboards or predictive models. Let me now walk you through one of the most important visuals for model readiness, how I address the severe class imbalance in the cancel target variable. Out of over 7.6 million flights, only about 3.3% were actually cancelled. That means if I trained model without addressing the imbalance, it could just predict not cancelled for everything and still be 97% accurate, but completely useless. So to fix this, I downsampled the majority class and then non-cancelled flights to about 300,000 records and retained the 251,874 cancelled ones. That gave me a training data set of around 552,000 records with a nearly 45-55 balance. This balanced distribution allowed me to apply machine learning models more fairly, especially in sample models like random forest and XGBoost, which tend to overfit if the classes are skewed. So these visuals directly respond to my assignment 3 feedback and strengthen the modeling workflow for the next assignments. The key lesson learned this week is the importance of simplifying slide content and targeting visuals of highlighting model-ready features and KPIs. I also realized that FSFT data, though not always predictive, adds contextual depth that can really refine the project scope. Addressing class imbalance and justifying feature choices clearly was critical to improving both model performance and rubric alignment. Um, Next, as I transition to the final phase of the Capstone project, my next steps include completing the modeling pipeline using the stratified train test split, then applying tuning models like random, forest, and XGBoost, and logistic regression. I will compare their performance using the metrics like precision, recall, F1 score, and AUC, with special attention to how well each model handles the imbalanced cancelled target. I also plan to explore how FA incident patterns might enhance predictions or be used as a post-model validation. Additionally, I will begin drafting my Tableau dashboard, which will summarize the key cancellations and delay insights for presentation 3. These tasks will ensure the project delivers both operational and predictive value. These are the references that I used for my visualization. Mm, Thank you for your time. Appreciate it.